the previous video, we have discussed how Anker Power IQ works. But how do Qualcomm Quick Charge and MediaTek Pump Express work? What is spare current charging? What is current modulation? All of these questions will be answered in this video. If there is anything unclear about the following video, or if you have any suggestions, do not hesitate to leave a comment. Qualcomm Quick Charge and MediaTek Pump Express are protocols through which a mobile phone communicates to a charger in order to request a different voltage than 5 volts, either to increase the charging efficiency at higher currents by matching the internal battery voltage of the phone, also known from Huawei Supercharge, or for the main reason. The idea for the Quick Charge protocol originated before USB-C, which supports 5 ampere of current, was common in mobile phones. Due to the limited current the former USB-B connector could handle, they had to increase another variable to increase the total charging wattage, which is the voltage. A higher voltage at the same current does increase the power throughput without producing any additional heat inside the copper wires of the USB cable. This elevated voltage gets converted down to the lithium-ion or lithium polymer battery charging voltage of around 4.3 volts inside the phone using an integrated buck converter. The two early standards for requesting an elevated voltage from the power supply were Qualcomm Quick Charging and MediaTek Pump Express. While Qualcomm's protocol communicates to the charger utilizing the USB data lanes, the original version of MediaTek Pump Express utilized the main power lines themselves for communication, by toggling the current drawing in specific intervals that represent information interpreted by the power supply, also known as current modulation. The first widespread version of Qualcomm Quick Charging was version 2.0. It originally only supported the voltage steps of 5 volts, 9 volts and 12 volts. Pump Express version 1 supported a 7 volt level in between. There was a so-called revision B of Qualcomm Quick Charge 2.0, adding a 20 volt mode for future-proofness and support for laptops, also covering the usual 15 volt requirement of larger tablets. However, the charging protocols soon were revised into the next round in 2016. Pump Express 2.0 now had a voltage range of 5 to 20 volts with half volt steps, while Qualcomm Quick Charge had 3.6 volts to 22 at 5th volt steps. Pump Express version 3 works in a similar way as Huawei Supercharge and OnePlus Charge, where the mobile phone requests voltage adjustments from the charger, until the voltage that arrives at the mobile phone matches the battery's internal voltage as accurately as possible. This reduces heat production by removing the need for coarse voltage regulation of high currents inside of the mobile phone. More and more mobile phone manufacturers are implementing USB-C power delivery, which does not use either of current modulation or data lanes for communication to the power supply, but rather the dedicated power delivery communication lane of double-ending USB-C cables. However, there is a serious limitation common in many mobile phones, deliberately induced by manufacturers. While the mobile phone is being utilized, the charging speed gets drastically reduced, rendering fast charging temporarily ineffective. The correct way to do is, which is how laptops have been doing it since ever, is the spare current method, where the charging speed is unaffected by device usage, because the device utilizes the spare output power of the power supply to power the device components while maintaining the original fast charging speed.